Okay, so for today we'll be looking at the friction force. So that's what we'll concentrate at on the friction force. So first of all, we need to define what the friction force is. So the friction force is a force that opposes the relative motion or tendency of motion between two surfaces, you know what, in contact. That's what we call what? Friction force. So this is the type of force that opposes the what? The motion. When something is moving or something that is just at stationary, right? So that's what we call what? Friction force. So we have some types of the friction force. I would say types of friction. What is that type? We have what we call static friction force. Then the other one is what we call what? Kinetic friction force. So for on this video, we just concentrate on the two types of the what? Friction force, which is a static friction force and what? Kinetic friction force. So when you talk about the static friction force, what do you really mean? So on the kinetic friction force, this is the type of the force or the friction force that make an object not to move. Like it's a force that will make an object not to move anywhere, even if the force is being applied into it, but it will try by all means not to make an object what? To move. How about the kinetic friction force? So the kinetic friction force, this is the type of the force that opposes an object to stop moving. So if you have something that is moving or going in this direction like that, so meaning that there will be a force that will be opposing this object to go back like that. So that's what we call what? That's what we call kinetic what? Friction force. So then the other thing that I can talk about is that how do we calculate this? How do you calculate this friction force? So this friction force, we calculate this friction force by saying F is equal to mu times the what? The normal force. So this mu, it depends on the type of the friction force. If the friction force is the static, meaning that the mu becomes as here like this. So how about if it's kinetic, meaning it becomes what? U like that, then what? K like that. So those are the main what? Types of the friction force. Okay, now we will look into how this friction force they resist the objects that are moving, or they resist the objects that are moving, whether in the x-axis and y-axis and just everything. All right. So how? So for example, I can say when I have the object which is like this, right? Now I'm pulling this object horizontally. I'm pulling this object horizontally, not at an angle, but I'm pulling this object which is the horizontal like that, right? So if I'm pulling this object in horizontal like that, meaning that I have to identify the forces that are acting on this object. So if this object is moving like that, right? Meaning that the friction force will be going like that. So that's a point where the friction force will go like that. Is it okay? Then our forces in the y-axis will have the force there, which is the what we call normal force. And down part here, we have the force what we call what? That we call what? Gravitation force. So for us to identify the forces or the summation of all the forces that are acting on this object, what are you supposed to do? Remember that according to the Cartesian plane, according to a Cartesian plane like this point is positive, this point is negative, and this point is what? Positive, and this point is what? Negative. So what are you supposed to do for us to come up with all the summation of these forces? So what are you supposed to do is you have to say what? Summation of the forces in the x-axis is equal to, so if we're dealing with something that in the x-axis, something that we're dealing with the force that is being put and the force that is not resisting. So remember, this force that is being put, it's going to the positive direction like that. So we have to say what? FP, which is the put force, minus the what? The friction force, like that. So these are the forces that are in what? In the x-axis. So if these are the forces that are in the x-axis, like that, how about the forces that are in the y-axis? So we say summation of the forces in the y-axis will be this force which is here, it is the going up, like that, right? So meaning that the normal force will be what? Minus this one which is going down to the negative direction. So it will be what? Mg, like that. So these are the forces in the what? In the y-axis, and these are the forces in the what? In the x-axis. So if these are the forces in the y-axis and these are the forces in the x-axis. So now for you to calculate the acceleration in this situation, so you have your equation 1 and this is this what? Equation 2. So you have this force in the x-axis and this force in the y-axis. So these are the main forces that you have on this type of the pull system, like that, right? So if, for example, if they ask you to calculate the acceleration, what are you supposed to do here in this situation? So in this situation, the only part that it has the acceleration, it is in the x-axis, and this part doesn't have the what? The acceleration, which is the y-axis. So how do you find that one? You say, you just, here where the summation of forces in the x-axis, you just change that part, you put it as what? Ma is equal to what? F, which is the put force, minus what? Friction force, like that. Then remember that in the y-axis there's no what? There's no acceleration. So meaning that in the y-axis the acceleration is what? Is 0. So if the acceleration is 0 in the y-axis, meaning that here you say what? 0, 0, then F n minus what? Mg, like that. So those are the things, right? So let's make the normal force with the subjective formula. If you make the normal force with the subjective formula, meaning this will go this side, then it will be positive, like that. Remember that you have this equation which is here, right? We want to calculate the acceleration at which this object was moving. So meaning that you're supposed to say what? Ma, like that, right? Is equal to the pull force minus the friction force. Remember that how do we calculate the friction force? The friction force, we calculate it in this way. We say it's mu, then what? The normal force. Then what will happen? It will be where there's the friction force, we substitute that meaning to the what? Mu, then the normal force, such that you come up with something like this is the pull force here minus what's the mu? Mu here, then the normal force is m, like that, and then you end up having an equation which is a f p minus mu, then what? Mg over m. So this is how you calculate for the what? Acceleration in this situation. So that's how you do that one. Then let's go on the other one. Now if this object is moving in the what? If this object now is being pulled at a certain angle, here where it was just being pulled horizontally, but now if this object now is being pulled in what? At an angle. So what are you supposed to do in that situation? So for example, I can say if you have this object which is here, is being pulled horizontally like this, right? So this is the pull force, which is there, right? It's being put horizontal like that, meaning that, oh, it's being put at a certain angle like that, meaning that this is your f theta, like that, right? Then this is your y-axis, like that. So let's identify all the forces that are here. So the forces that are here would what? On top here would be what we call force. Down here it is what we call gravitation what? Force. Remember what is happening is that if you're pulling the object going in this direction, meaning that the friction force will be moving this direction. So meaning that the friction force is in this direction, like that. Now, remember that this object is being pulled at what? At an angle, meaning that the force is divided in the x-axis and the force is also divided in the what? The y-axis. So you have the x-axis and you have also the what? The y-axis, like that. So meaning that what are you going to find the force? How going to know if this object, if this force here was in the y-axis? So we need to know what force that was here in the y-axis. So according to the right angle triangle, right, if we have the theta here you have the pull force, I can say, right? Here we have the pulling force, like that, right? So meaning from here up to here, that's a pulling force, but we need to find the force in the y-axis and also need to find the force in the x-axis. So this is the opposite of what? This, and this is the adjacent, like that, right? So how are we going to find the force on the opposite? So that's where the situation comes in that we call SOHCAHTOA. So what does the SOHCAHTOA mean? This is sine, opposite, adjacent. So here we have the adjacent, which is FP, and the angle which is there. So meaning that for us to find this opposite side, what are we supposed to do? We can use this, right? So we say sine theta is equal to opposite over hypotenuse. So meaning that we have sine theta there. What's the opposite? It is still the opposite, is the one that you're looking for. Then what is the hypotenuse? The hypotenuse is from here up there, which is the FP. So meaning that it's FP. The opposite, let's make the opposite the subject formula, which is by say this time that to give us what P here is equal to FP sine what? Sine theta, like that. So meaning that the force which is here, it is FP sine theta. So here it will become FP sine what? Sine theta. So this was the force that was being put in the y-axis. How about the force that was being put in the x-axis? That's where now we have to find the adjacent, like that. We have cos adjacent over hypotenuse. Remember that we have already hypotenuse that side. So it means it will be what? It will be cos theta is equal to adjacent over hyp. So cos theta adjacent is the one that we're looking for. What is hypotenuse? Hypotenuse is what? P, like that. Let's make adjacent be subject to formula such that it will be this times that what is equal to FP cos theta, like that. So that's what you call FP cos what? Cos theta, like that. So meaning that here it's FP cos what? Cos theta, like that. So we have the force in the y-axis, which is FP cos theta, the x-axis, and the force in the y-axis, which is FP sin what? Sin theta. So from there now, let's arrange all the forces now that are acting on that object. So that's where now we say the summation of the forces in the x-axis and the summation of the forces in the what? In the y-axis. So let's do that. So let's do the summation of the forces in the x-axis. What are the forces that you are seeing in the y-axis? Remember, this side it's going to the positive, and this side is going to the negative, right? So the forces that are going to the positive side, which are they? We have FP cos what? Theta. So we have FP cos theta. How about the forces that are going to the negative side? We have minus friction force, like that. These are the forces that are only found in the what? In the x-axis. How about the forces that are found in the y-axis? That's where you have this situation where you have to say summation of forces in the y-axis. We have what? We have the normal force that is going up, like that, and the gravitational force that is going down. So it's mg here. And this force which is in the y-axis, remember that it's going where? It's going up, like that. So to be plus what? Fp then sine what? Sine theta. So remember that if you have been asked to calculate the acceleration, right, in this situation, so remember that the only acceleration goes in the x-axis, but doesn't go in the y-axis, right? So if it goes in the x-axis, meaning that you are only allowed to get the equation the x-axis. So say ma is equal to what? Fp cos what? Cos theta minus f, which is the friction force, right? Then here we have 0 in the y-axis, so it will be fp here minus mg plus what? Fp sine theta. So in this situation, if they ask you to, or this is sorry, this is supposed to be the normal force, sorry. So in this situation, if they ask you to calculate the normal force, what are you supposed to do? You just make Fn to the subject to the formula by saying what? Fn, like that. When this one goes to the other side, it becomes positive. So this one will be positive mg. But when this one goes to the other side, it becomes what you call it? Negative. So it will be negative Fp sine theta, like that. So that's the normal force. So I can say this the normal force in this situation. How about the acceleration? The acceleration in this situation, we use the first equation, which is here, which is supposed to just say ma, like that, is equal to f cos theta, like that, minus, remember this is the friction force, right? If that is the friction force, meaning what are you supposed to do? You have just to say mu, like that, right, times the normal force. So meaning that you'll be ma cos theta, like that, minus mu. What's the normal force we have? Mg, which is we're just equating now. You get this equation, you put where there's the normal force which is there, then minus what? Fp sine theta, like that. Then what you come up, you will make just a to be the subject to formula, which is the acceleration. Then the acceleration will be Fp, like that, cos theta minus this time that it is mg minus u, the force applied, sine theta, like that, over what? The mass. So this is how you find all these things. Oh, everyone is clear on that one. If you have a question, comment there, then I'll answer your question immediately. So how about when it comes to the incline system? So on the incline system now, right? On the incline system, I want you everyone to understand this part. On the incline system. On the incline system. So let's do now the incline. Incline, right? So what do I mean when I say the incline? Meaning that an object that is like this, right? Or that an object that is being put now on the incline, like at a certain angle, like that, right? So that's what we mean here. So we have this an object which is being put in this situation like that, right? So if you have this situation, right, it also depends which is here. Here, are we pulling this object at an angle, or we're not pulling this an object at an angle? So if you're pulling this object at an angle, right, I want you to look at this. If you're pulling this an object at an angle, meaning to be something else. But here, let's start with something that we're not pulling this object at an what? At an angle. We're just pulling this object like this, right? What is it? FP here, right? We're pulling this object horizontal. It's more like a horizontal. It's not at an angle shot, right? So what we need here is to identify all the forces that we are having here. So on top this side, we have what we call the normal force. But down here in this situation, the way it is that the gravitation force is somewhere here, right? Like that. I want you everyone to look at, you understand this part. So this theta which is here, the one theta that we are seeing here, it is the same with this angle which is where, which is here, because we are pulling this object at an angle. So the angle which is here and the angle which is here, they are the same, right? So remember that this side, it's mg, like that, right? So if from here up to there, it's the mg, meaning that what are we supposed to do for us to find this mg which will be here? So remember, when you use SOHCAHTOA, what will happen to the SOHCAHTOA? When you say SOHCAHTOA, right? So to use SOHCAHTOA, for you to find the opposite side here, meaning that you have to use what? Sine, right? The hypotenuse, which is this side, the hypotenuse, which is this side, right? The hypotenuse, which is this side, it's mg. So remember that time for you to find the opposite, this side, it should be what? Mg sine what? Sine theta, like that. How about for you to find this adjacent, which is this side? We use what? To know what? Mg and what? Cos theta, like that, right? So I hope you're seeing the differences. If I find the opposite side by using SOHCAHTOA method here, I'll find that it will be mg sine what? Sine theta. I don't know if you are getting that, but the only thing that I'm saying is this. I want you to look at this. This is the opposite. This is the what? Height. So what's the opposite here? The opposite is this side here. This is the opposite, right? And this is the what? Adjacent. And this is the what? The height. So the height is what? Or the hypotenuse. The hypotenuse is mg. So meaning that we have sine theta here, opposite, over the hypotenuse. So meaning that the hypotenuse, the opposite of what? This one, the hypotenuse is what? It's mg, sorry. The hypotenuse is what? It's mg. So that's the hypotenuse. So the hypotenuse is mg like this. Meaning we have to multiply this one times this one, this one times this one, right? So to be opposite is equal to what? Mg sine what? Sine theta. So that's where this is coming from. If you do the same thing for you to find the adjacent, you arrive at this. So in short, what I'm just trying to say here is that in the incline system, the sine will go to the x-axis. Then the cos will go into the y-axis, in short like that, right? So that's the main reason that I'm saying about this, right? So I want you also to look at this. So if the force here, the force which is coming down here is mg cos theta, right? Meaning that the one that is pulling this down here, we're pulling this object like this, meaning here you have two things, right? You have friction force that is pulling this down, and we have the gravitation force. Which gravitation force? Remember that this part, it is equal to this part. So meaning that the one that is the other force that is pulling this down, it is what we call what? Mg sine what? Theta, like that. So those are the situations that you really need to look at in this situation, right? So after we have discovered all the forces on this, let's go to and we say what? Summation of the forces in x-axis. What are the summation of the forces in x-axis? Let's look at the summation of the forces in x-axis. We have this force that is pulling going up. If we have this force that is pulling this object to go up, so to FP here, then we have these two forces that are going to the negative side, this side, right? Which is it? So we have to say minus what? Friction force minus the gravitation force that is in the x-axis, like that. So if you have been asked to calculate the acceleration this side in this situation, you say ma is equal to what? Fp minus f then mg sine theta, like that. So that is what you call equation what? Equation 1. So how about the equation 2 in the y-axis? So you have to say the summation of the forces in the y-axis is equal to what? So you have the force that is going up like that. So that's the force that is going up like that is a normal force, right? And it is going to the positive direction. And we have the force that is coming down, which is mg cos what? Cos theta, and it's going to the negative direction. So it will be mg cos what? Cos theta. Remember, it's going to the negative direction. So in this situation, we don't have any acceleration in what? In the y-axis. Such that the normal force will be Fn is equal to mg then cos what? Cos theta. So we have made the subject to formula, which is the normal force. So here, this is our normal force, right? Then the next thing that you need to know is what we call the what? What we call the what? The acceleration now, right? So remember that the acceleration, you can only find the acceleration when you get the equation for the x-axis. So which one, the equation for the x-axis is the equation for the x-axis, right? Let's get that equation, which is for the x-axis. So we say ma like that, right, is equal to F, which is the put force, minus this is the friction force. So if this is the friction force, meaning how here is supposed to be what? Mu times the what? Normal force minus m g sine what? Theta, like that. So what's the ma here? Ma is equal to what? F here minus mu. So what is here, you replace with the normal force, which is this, the normal force which is there. So to be mg cos what? Cos theta minus mg sin theta. Then what you end up, you end up with something like this. So if you have been asked to calculate the acceleration in this situation, you use this formula or this method, the one that I've shared now, over. So this is how you come up with the equations, right? So this is how you come up with the equations on this situation, right? Yeah, so remember the key points that I'm saying here. If you look at this, we are using the what? We are putting this object horizontally. It's not at an angle. So the next one, let's do at an what? At an angle now. So remember that we're still doing incline. So the incline, do like that. Right? Now let's take this now. It's being pulled at a certain angle. Being pulled now at a certain angle. So we have an object which is there, is here. Then you remember that is being put at an angle. The one that we were doing, it was not being put at an angle, right? So but this one now is being put at an angle. So what you do is just the same thing that we are doing there, right? So remember that if this object is being put at an angle, right, meaning that this angle here, meaning that we have the forces are divided into two, which suppose the one that are going in the x-axis and the one that are going in the what? In the y-axis. So how do you do that one? Remember that one which is F here, P, right? Then sin what? Sin theta. Like that. Here, how about this part? We have P here and cos what? Cos theta. When we use Sokatoa method, right? When you use what? Sokatoa method, this is the opposite This is what? Adjacent. So for you to find the opposite side and we make the circuit to the formula, meaning that we will arrive at what? FP. We will arrive at FP sine what? Sine theta, like that. So that's why I've just gone direct like that, right? Now, okay. How about the forces that are down here? We have the force that is up, which is what? The force. And remember that we have the forces that move like this, right? Right? This is mg. Remember, this angle is equal to this angle. So we have mg cos what? Cos theta. When you use Stochastic, this is the angle, which is this is adjacent. This is the hypotenuse. This is what? Opposite. Here you come up with what we call mg then what? Theta, like that, right? Then what will happen is that if you're pulling an object, it's going in this direction, meaning that your friction force will go like this. And you have the mg. Remember that this one and the down part here, they are the same. So it's mg sine what? Sine theta. This is what gravitation force in the x-axis. So let's do the same thing now. We say summation of the forces in the x-axis. What are the forces that we have in the x-axis? We have this put force, which is here, right, at this angle, right? So it means to F cos theta, like that. Then we have the down force, which is going down, which is what? Mg sine theta, like that. So for you to calculate the acceleration in this situation, you have to say Ma is equal to what? Fp cos theta minus Mg sine theta, like that, right? How about the summation of the forces in the y-axis? So summation of the forces in the y-axis. What are you supposed to do in this situation? You have the forces that are going up. It's Fn here, right? That's a normal force. Then the down force we have Mg minus here, right? Mg cos what? Cos theta. Remember that we have all again this force, which is this side. So meaning it will be positive what? F, which is the put force, then sine what? Sine theta, like that. Remember in this situation that the x-axis there is no any acceleration, meaning it will be 0, like that. F n here minus Mg cos theta plus F sine what? Sine theta, like that. Now let's make Fn to be the subject to formula so that we can calculate what? The normal force. So in this situation, when this one goes to the other side, it will be positive. When this one goes to the other side, it will be what? Negative. Right? So meaning that in this situation, our normal force, this is how our normal force is, right? So if this is your normal force, meaning that we can even also calculate the what? The friction force. Oh, sorry, here on the x-axis, we forgot one force, which is the friction force. So meaning that here, suppose MA, we have FP, the put force, cos theta, minus the gravitation force, which is Mg sin theta. Again, we have this friction force, which is minus what? F. So meaning here again, supposed to be minus F. Sorry for that, sorry for that. So meaning that for you to calculate the acceleration now, say Ma is equal to Fp here, then cos what? Cos theta, minus mg sine theta minus. Remember the friction force, that's mu, right? And like that. So meaning it will be Ma here is equal to Fp cos theta minus Mg sine theta minus mu here. What's C here? The normal force. The normal force is Mg here cos theta minus Fp sine what? Theta, like that. So meaning that what we're going to have, we have Ma here is equal to Fp cos theta minus Mg sine theta minus, when you multiply there, it will be mu Mg cos theta plus, remember here it's minus, such that when you multiply here to be negative here, but this one when you multiply that one will be what? Positive. So to be mu F, which is the put force, like that, right? Then you calculate the acceleration in this situation. So okay, I was thinking if maybe they ask you to calculate the acceleration. Now if they ask you to calculate the put force, what are you supposed to do in this situation? So in this situation, that's where you have to, in this situation, that's where you have to what? To make this put force to be the subject of what? Of the formula. So meaning that we need to, after entering everything here, right? So we'll be looking for what? This put force. We make this to be what? A subject of formula. I think the other video will be uploaded very soon about how you can do that one. Okay. So how about the pulley system? Maybe on the table or somewhere else, right? So we have let's just do a bit of the pulley system, the basics. The pulley system, for example, we have something like this, right? This is M1 and this is what? M2. So the best way on dealing this, what you need to know is to identification of the forces, and you have to know on how all these things go like, right? So let's start with this one, right? Let's draw a free diagram. How are we going to draw the free diagram of this? So remember that maybe they ask you to calculate the tension in this rope and the acceleration at which these objects were moving, right? So in this situation, I want you guys to understand it clearly. In that situation, what you really need to do in this situation is this. One, let's draw the free diagram. So the free diagram here, remember that we've been asked to calculate the tension. So let's say calculate the tension in this situation. So I mean that where there's T and here it's frictionless, there the pulley is what? Frictionless. So meaning that it's going like this, right? Is it okay? So if it's going like this, right? Meaning T is equal to this, right? Then it depends sometimes. Sometimes they'll say that there's friction force between this M1 and the table, right? So let's start with the one that is frictionless. So meaning I can say here frictionless. So here if they say it's what? Frictionless. The M1 and also the surface of the table, it's frictionless. So meaning there's no what? Friction. So how are you going to make the equations on this part? So remember this one is going this way. So the point where it is going, it becomes what we call positive. Then the point where it is coming from, it becomes what? Negative. So in this situation, we have, they said that it's frictionless, right? We have the force which is up here and the force which is down, which is what? The mg, right? So in this situation, for you to come up with the formula, right, if it's frictionless, meaning that the y-axis is pointless, so what are you supposed to just to do? You have just to say ma here. Remember that it's going in this direction, so meaning that t will be positive, like that, right? How about this? About that, we have tension, which is on top there, and we have mg. So you have to put even m1 in. We have mg here, right? Mg, which is doing like that, right? Remember that I said that it's going down, it's going like this, right? So if it's going like this, meaning that where it is coming from is negative. So meaning this point it's negative, and where it's going is what? Positive. So if it's like that, meaning what are you supposed to do in this situation? You have to say what? Ma. Remember what is positive now, where it is going, it's going to the gravitation, which is positive. So meaning to be mg, which is positive. Then where it's coming from, where the tension is, it becomes what? Negative. So this is your equation 1, and this is your equation what? Equation 2. So what are you supposed to do in this situation for you to find the acceleration? So you have the equation, they're saying ma is equal to what? T1. So this is the mass 1. Then for mass 2, which is ma is equal to m2g here minus t. So what are you supposed to do? Here we can just say m2a, right, minus. So where there's t here in this situation, we replace with that, meaning it will be m1a, so that we can find the acceleration. When it goes the other side, to be what? Positive. It will be positive like this. So it is mg, ma like that is equal to mg. So what you do here in this situation, you just find the what? Just find the acceleration.